This is a video about how to compare means in ANOVA, how to do the post hoc tests. Let's say we run an ANOVA. Go Analyze, we have the group factor and the statistics quiz. We go into Analyze, compare means, one-way ANOVA. We choose group as the factor, the stats quiz as a dependent variable. We check the descriptive statistics and the homogeneity test, and then we hit paste. We let the syntax be pasted into the syntax file here. And you can write something as a title. If you mark a star in the beginning of a line, the program will ignore this. It will see, okay, this is a star, this is the text. This is what we use to annotate the syntax. So this is syntax for the ANOVA. You see it also in blue. It's not relevant. So then relevant to the computer. Now we highlight this section here, which is the program which speaks to PSPP. Run this selection, and now if we go into the output, we see it ran the ANOVA. Now we find the descriptives here, the test of homogeneity of variances here, and the ANOVA down here, and the F value is significant. So we know somewhere in here there's a significant difference. Now, PSPP does not allow you to test these differences within the point and click menu here. For example, in SPSS, you can do this with the menu, but in PSPP you have to go through the syntax. So what we do is we add a line. I'm just gonna copy this section here, and I'm gonna name this ANOVA with the post hoc test. And we're going to take this dot away. That's important because the dot means that here the program stops. So take the dot away, we start a new line, backslash, and we type post hoc. Oh, I forgot the P. Post hoc. And we want the LSD post hoc test and the Sheffy. And now Sheffy has two F's. And now we hit the dot, and this means that this is the end. So in addition to the statistics, the descriptors, and the homogeneity, we also want the post hoc. So we select this syntax, and again we run the selection. And now if we go into the output, we should have gotten, again, the beginning is the same, descriptives, test of the homogeneity of variances, the ANOVA, and now down here we also have the multiple comparisons. So what this is the comparison of each group with each other. So first here in this box is the LSD, and then the next one is the Sheffy. They basically do the same thing, right? They test the significance of the mean difference. The LSD is less strict and the Sheffy is more strict. So if you want to be less strict to find a significant difference, you can use the LSD. If it's important to be stricter, more conservative, you can use the Sheffy. So for the online section, compared with the lecturing section, we have a mean difference of 0.60. So let's go check if that's true. Online section is 13.8. The lecture section is 13.2. Yes, if we look at 13.8 minus 13.2, we get 0.60. That's correct. Now we have a standard error of 0.77, and note that the standard error is the same for all the comparisons. So we have mean difference here, 0.60, standard 0.77, and then the significance of this mean difference, because it's much larger than 0.05, it's not significant. We conclude there's no statistically significant difference between the online section and the lecture section. Now the next comparison is online section and independent study section, 2.60. So we see here a 2-point larger difference, right? If we compare up here, we see 13.8 for the online section and independent study section 11.2. So yes, 2.6 points difference. Same standard there, 0.77. Here, that's highly significant. So we say that there's a statistically significant difference between the online section and the independent study section. And finally, the last comparison between the online section and the combined section is negative 0.8. So the online section, 13.8, is 0.8 points lower than the combined section, 14.6. Now, is it significantly lower? Compare again, negative 0.8, and the significance here again higher than 0.05. So we say we conclude that there is no statistically significant difference. The only difference here is between the online section and the independent study section. So we compare the online section with all three others, and now we move on to compare the lecture section with the online section. We did that already. You can see here minus 0.60, 0.77, 0.45. The only difference here is the sign, right? The sign of the difference because here we go from online to lecture, it's a positive difference. If we go from lecture to online, it's a negative difference. Right? Let's see here. If we say 13.8 minus 13.2, we get a positive difference of 0.060. If we go from lecture, 13.2 minus 13.8, we go below 0, it's minus 0.60. So the difference is the same, it just matters what you compare with what comes first. Now, but we've had this already up here. Like, what's new is the lecture section compared with the independent study section. Here we have a difference of 2, and here this is highly significant. It's lower than 0.05. So I would say there's a significant difference between the lecture section and the independent study section. The lecture section is 2 points higher than the independent study section, and that is a statistically significant result. Now if we compare the lecture section with the combined section, we see that the lecture section is minus 1.4 points, so it's 1.4 points lower than the combined section. Let's look up here, and again we see lecture section is 13.2 points, the combined section has 14.6 points, so yes, there's a 1.4 points difference. Now this here is not statistically significant. The p-value is higher than 0.05, so we say that there's no statistical significant difference between lecture section 2 and the combined section 4. Now we have one more comparison to make, that's between the independent study section 3 and the combined section 4. We see here a big difference of minus 3.4. We see that it also is highly significant. Right? This is the biggest difference that we've found so far. And then the combined section 4 with all the other three groups basically repeats the results that we found before, but it's all positive because the combined section is the section with the highest score. So we see here, although it's the highest, the combined section is only significantly higher than the independent study section, not higher than the lecture section, and not statistically higher than the online section. So to summarize the results of the LSD, right, with ANOVA we found there is some differences between those groups, and now the LSD multiple comparisons tell us there's one significant difference between online section 1 and independent study, right here. There's one significant difference between the lecture section and independent study, and there is another significant difference between independent study and the combined section. So this would cover all our significant differences. Now if we go and look at the Sheffy, we're doing the same thing. You see here the differences are exactly the same. The standard error is exactly the same, but the way that we calculate the significance of these results is different. So it's more conservative. And an example for this is, if we see the first difference, 0.60, 0.77, the Sheffy will give you a probability, a significance level of 0.89, whereas the LSD would give you a significance of 0.45. So here the Sheffy is much higher, almost twice as high. Now if you go to the next result for the independent studies section, the Sheffy would conclude that there's a significant difference, right? 0.03, it's lower than 0.05, but you are it's less significant than with the LSD. Now here, so far, we would have no different conclusions, right? We would have the same conclusions. First difference, not significant. Second difference, significant. Now let's look at the comparison from the lecture section 2 with the independent study section 3. Here you have 0.02 significance, and with the Sheffy you have a 0.12 significance. So if you would use the LSD, here you would conclude there's a significant difference because it's lower than 0.05. And if you would use the Sheffy test over here, you would conclude that there's no significant difference because the p-value is higher than 0.05. So you see how these results, there's an area where these two tests will disagree, where one test will say it's significant and the other test will say it's not significant. So that's why it matters that when you describe your results to explain which post hoc comparison did you use. And if you know a little bit something about statistics, if somebody says I used the LSD, you know that they're testing their comparisons a bit less conservative, and if somebody reports to you that they're using the Sheffy test, you would know that their tests are more conservative. And sometimes there's debates between people which test you should use. So this is how you do post hoc comparisons. Now as far as the syntax goes, what you can do is save your syntax so that you can use it for next time again. That's where the value of the syntax really comes in. So I'm going to use, you choose a good folder where it makes sense that you can save it. And you can find it again, and I say here ANOVA for book example page 166, and then this will be saved as a syntax file .sps, and I hit save. Now you can open this at any time and again run it. This was a video about how to do the post hoc comparisons in PSPP.